Hi, good morning. This is Prem Kumar, Assistant Professor, Department of Computer Science. Today we're going to see about the subject Computer Architecture Microprocessor Lab Program 16-bit edition. So we'll see the algorithm part of this 16-bit addition. Now first we're going to do what this is. We're going to have the two memory location that is used to storing the two 16-bit data. So after getting this data, that is, we'll store that first 16-bit data to the HL and the other 16-bit data to the DE register pair. And we'll be initializing the one more register, the C. It is to store if any carry occurs, we'll be incrementing the C register, or otherwise it has retained as it is as 0. The next step what we have is we're going to add the register pair with using the instruction DAD. The DAD is the instruction, that is DAD instruction. It is used to it is used for adding the register pair contents and store the data again in the HL register pair. And after adding it, we'll be checking if there is any carry occurs or not. If carry occurs, we'll increment the C register by 1. Otherwise, we have the C register, what is the initial value it has been assigned, it has been staying there. And after storing all the result, what we have after implementing the C register and addition operations, we used to store the result in the successive memory location, that is sum in the one location and the carry is in another location. We'll see the flowchart part of this part. That is, after starting the program, the string that is the HL is pointing to the first operand and the DE register pair is pointing the second operand. So that is, the first 16-bit data is stored in HL and the second 16-bit data is stored in the DE registers. So what was the next operation we have, that is, we'll be going for the addition operation, that is, the C register is going to have the low order address and the B register is, it is for the carry purpose as I told you before. The B register is going to do the addition operation along with the carry flag. So the C is going to add the least significant bit and the B register is going to add the most significant bit along with the carry. After adding that, what we have is we will be storing the result in the memory location. While storing the data in the memory location, what we are doing is we use to check if there is any carry occurs or not. If the carry bit occurs, we will increment the value that C register to 1 and that is being stored in the memory location also. If there is no carry occurs, so we don't need to worry about that. We will be incrementing memory location and we used to store the 0 what we have initialized initially it as. We'll see the program now. See this. So first what we have, that is in the memory location 8000 is we have the mnemonic, that is LHLD. It is load the HL register pair. That is, we'll be loading the data from the 8030 to L and 8031 to the H. And the second one is we'll exchange. What is the second instruction is? It is a 3-byte instruction. So 8000, 8001, 8002 has been used for the mnemonics LHLD. And the second line, what is the program we have, that is 8003, we have exchange. Exchange is we will be exchanging the memory location content to the DE register pair. That is the use of the exchange. Exchange is nothing but we will be moving the HL content to the DE register pair. And then the third instruction is 8004. What the instruction 8004 line have is, again we'll be incrementing. We're going to load the second data, 16-bit data, that is LHLD. So 8032 and 8033 data, what is we have in that memory location, the data is again we carried loaded into the memory location to the register pair HL. And the fourth instruction we have, that is we have the immediate data for carry purpose. So we have that MVI C. So C is going to have the value of 0 now. And the next instruction is we're going to do the register pair addition operation. That is we have it in the address 8009 DAD instruction. DAD D is nothing but we have one 16-bit data in HL and other 16-bit data in DE register pair. So that is it is going to perform, that is HL is equal to HL plus DE. HL is equal to HL plus DE. That is what we have here. The next one is 8000A. The 8000A, what we have here is we're going to check the carry bit if there is any carry occurs or not. So if there is any carry occurs, what we have is we'll be checking by this condition jump not carry. If there is no carry, we will be skipping this line. So we will moving on to the memory location that is 8000E. That is, we will store the data what we have in the HL register pair to this memory location 8040. See this, store the result in 8040 and 8041. So we have the result in HL. No, this HL data, the low order data is going to store it in 8041, and the high order bit of the data is stored in 8041. 40 is to have the low order bit, and 41 is have the high order bit. That is a instruction it says. And again, the next instruction what we have, that is, we'll be moving the C register to the accumulator. We'll store the C register to the accumulator, and that result has been that accumulator result will be stored in the accumulator. That is, we are saying that we have moved the carry result in the accumulator. That carry result which we have it in the accumulator now, that is also stored in the memory location, that is 8040. This is the process of if there is no carry occurs. If in case any carry occurs, what we have to do is we have to increment the memory. We have to increment the C register which has been initialized. Initially it was 00. If any carry occurs, we will be increment the C register by 1, and as usual, we will store the result in HL register pair, and to move that carry result to the accumulator and store that accumulator content to the memory location. So this is the process of your 16-bit addition operation. We will see the manual calculation progress. See this 8031, one 8-bit, and 8031 has another 8-bit. So these two combined as one 16-bit data, and the another 16-bit data is going to be stored in the 8031 as a 12, and another 8-bit data is in a 834. These two combines to form a 16-bit. So this is one 16-bit number, and this is another 16-bit number. When we add these two 16-bit numbers, we'll get the low order result as 24 and high order data as 48. So we don't have any carry over there. So as of this input, we are not getting any carry. So the result for this is 1, 4, the low order is 1, 2, and high order is 1, 5 for the first 16-bit data. And the second high order data is 12. Low order bit is 12 and high order data is 34. When we add these two, we'll be getting 4824 as a result. Okay. So this is the low order bit 24 has been mentioned it as here, and high order data is mentioned it as here in the location. And when we add these two 16-bit data, we doesn't get any carry. So the carry is as it is remains it as 0. That is also stored in the memory location 8042. Hope you all understand this 16-bit addition program. Thank you.